Okay, so we are talking about industrial IoT, and we need separate sensors such as like temperature, pressure, fluid monitoring, air quality monitoring, sensors which are robust to challenging environments, and we require processing. Uh, Units such as PLCs, programmable logic controllers, to do the processing at the local area and communicate that to the central location of processing the data. The programmable logic controllers are directly connected to the sensors, and the programmable logic controller will be like the embedded system in the normal IoT networks. So we talked about different embedded systems, containing different microcontrollers. So the embedded system in the industrial scenario will consist of the PLCs, the sensors, and the communication modules that are included in this PLCs for communication. Communication. So the sensor node will consist of communication module, PLC, and sensors basically. And the PLCs will be connected to the main processing, server, which will collect all the data from different PLCs. So the data will be analyzed by humans using computers. However, most of the time, the server will use that data within the local area network and not really share all that information with another entity in the in another place in the world. So sometimes that what I mean is that the server might not be connected to the internet. So it might only be working in the local area network, and maybe only having the information regarding the local area network. They will be collecting the local data and doing the necessary processing and giving back the feedback to the processing units. So the local data processing will be done, and feedback will be given. So this could be considered as the kind of traditional method of doing communication and processing in manufacturing facilities, and not only factories, not only manufacturing facilities, but we need this sort of a setup in healthcare industry, where we work with machines that collect information from sensors and pass that information to a central server or a computer, from which the health workers can get information regarding maybe patients and their conditions. And these IoT applications are also available for logistics and transportation, and in other sectors. So therefore, not only industrial scenario, but also other domains can also be considered for industrial IoT applications. So in those scenarios, we will be using basically some very robust sensors and PLCs to do processing of the data. Industrial IoT concept means that we are connecting the server, the central server in the local network, to the public internet. And then in the public internet, in one of the servers that is connected to the internet, we can store our information, which means we are able to store our information in the cloud. So after storing the information in the cloud, we can do cloud computing, and then from the cloud computing we can get some more like computation done, and more accurate or more fast processing of data done. So cloud computing uh, can be added to this industrial scenario by connecting our local networks to the public internet. Okay, so we need to have a connection to the cloud servers, and then any server or any person from another area on the earth can access our industrial server and access the data there. So actually, we need to be concerned about the security of the data. We need to consider about the people who are accessing the data. So in there, we need to give them like suitable authentication, like usernames and passwords, and only the authorized persons should be allowed inside this cloud service. So industrial scenarios, as you I think probably know, are very secure places. The data in the secure industries cannot be shared with like normal people who do not have the um, access to such kind of data, or who are not allowed to have such data. So the security of the data is a challenge, and it must be implemented in this type of networks where the internet is connected. So industrial IoT means the industrial networks which have connection to the cloud servers and the internet, and have have uh, have the features of connectivity to its sensors. So IoT, I think you already know what IoT is. So basically, the only difference here is that in the industrial scenarios, if it is not connected to the internet and it is not connected to anywhere on earth, then making the connection, establishing the connection from the local infrastructure area, uh, and the public internet uh, is allowing that infrastructure to be connected to the internet, and after that we can also allow that data that is communicated to the internet to be stored somewhere in the internet, where the data that is stored uh, can be further processed inside cloud servers, and cloud servers can give back feedback, useful information to the industry and to the managers of the industry, and so on. And also the manager of the industry can access the situation of the industry from a remote location. They do not have to come to the industry, but they can monitor the status of the industry by remote location, maybe in their own office in another location. So if you have any questions, please let me know. We will start with some history about the industrial IoT. So before industrial IoT came into being, there were different like revolutions that happened in the industry. So we will talk about such kind of revolutions that happen. So uh, industrial revolutions have throughout the history since the beginning of about 14th century. Industrial Revolution 0.0 is known to be started by the introduction of the printing press. So it's introduction of the printing press, which is known to be the first industrial facility in the world. So it has been done by German, Goldsmith, German Goldsmith, known as Johannes Gutenberg, and it is known as the first industrial facility. Then Industrial Revolution 1.0. Industrial 1.0 has been during 17th century, and it has been happening during the time where the steam engine was invented, and with that the industries were able to escalate with the inventions and improve their efficiency in terms of production and innovation. So they were able to create new products, improve the efficiency of the production rate, and use this steam energy to do the production. In Industry 2.0 has happened in 18th century. So this is basically regarding usage of um, electricity to run machines and do the work of productions. So utilization of electricity for mass productions. Then we can talk about the Industrial Revolution 3.0, which has happened in 19th century, 1969, around that time, where computer-driven systems were added to the industries. Next, we come to Industry 4.0, which is what is currently available in the present moment. So this is available in this current moment. So 19th century, maybe in the 20th century. So basically, connectivity of devices being added to the industry. Yes, so local data server is connected to the cloud via existing internet. Yes, so that's a good question. So I will draw the normal, internet like network. So we have, for example, some sensors. So these sensors are like sensor nodes, let's say, right? Okay, sensor nodes means sensors plus the embedded controllers. Microcontrollers, right? Microcontrollers like Arduino. The microcontroller based boards actually are combined with sensors and communication modules are used. Uh, Combine, and when we combine these three, we call as sensor nodes. So the sensor nodes, as you know, they collect information, they collect data. The data will be collected or will be transmitted to a certain access point. This could be a base station or a router, right? So after we can collect we can collect data in a wireless manner or a wired manner, right? So after collecting the data at a certain access point to the internet, right? So it will be having some connection. It will be connected to a certain router, right? So this router will be connected to the other routers, right? So the public internet is the collection of routers or switches, routers and switches, which constitute uh, the uh, which constitute the routes to all the other devices that are connected to the internet. So by going through these routers and switches, we can access other devices that are connected to the internet. So will be collected, will be passing through these routers and switches, and will be connected to the cloud servers. Right, so the cloud servers will be connected to one of these routers and switches. So cloud server is like another computer, right? So it's not a router, it is a server, it is a computer which will be located somewhere away from the access point, which we initially used to collect the data. Access point could be in Sri Lanka, and the cloud server could be in USA. So the data has to go through the public internet to access the server. Once the data is accessing the correct router which is connected to the server, the data can be transmitted to the server, and then the data will be processed in the server, and you can access this server from anywhere in the world. So you can be from your own computer. So from your own computer, you can access the server using the route that is available through the internet to the server, and then from that server, you can visualize the data in the server. So the server contains data about your IoT network. That IoT data will be and it will be shown to you via your computer. So I hope it is clear to you. So I hope it is clear to you. Okay, thank you. So I will resume introduction to the industrial revolution part. So with the different inventions during the history, during the years in the history, we have different versions of industrial revolution. So we have zero is also, I think, going to come next. However, we are only going to be talking about the industrial 4.0, which is available currently, right? So industrial 4.0, the industrial revolution available in the 20th century, which focuses on the connectivity of devices, right? So what is this connectivity of devices, right? So they are basically talking about the uh, IoT and the Internet of Things. That means connectivity between things. So in the industrial scenario, how can we ensure the connectivity, right? So in industrial IoT, so what that is the question that we need to answer, right? In industrial scenarios, we can have sensor nodes, as I said, sensor nodes, right? So sensor node means the collection of the sensors, microcontrollers, and communication modules, right? So all the combination we call as sensor nodes. Then sensor nodes, like in the factory, there could be other types of sensors. So that we will take, for example, like set of temperature sensors, at some router, let's say, right inside a certain factory, we can have a router, and this router will be connected to the internet, right? So then within the facility also we can have different routers, and the another facility facility could be somewhere away from this location, which is, let's say now there's a city, let's say this industry is in Colombo, another industry is in Horana or something. Then that location will have a certain other access point, which connects the data from that industry to the internet. So the collection of data will happen at another location, in another industrial facility, and that data will also be connected to the internet. And all these will can be stored in a certain separate cloud server, which is specified for this industrial facility. So we will take this industrial company is like Orange, let's say Orange company, which is making switches and equipments related to electronics. So Orange company is having two different industry facilities. It is having one in Colombo and one in Horana. The data that is collected from the sensor nodes will be transmitted to the internet via routers and switches, and the data will, right? So I mean, this is what industrial IoT means, right? So like you have a certain factory in the local area, and you have another facility in another local area, and the different facilities in different locations are sending the data to the cloud server, where the data will be stored, right? So in this location, we have connectivity in multiple places. We can have connectivity like with a remote user, right? A remote user can connect to the cloud server and gain data about the industrial facilities current status. What is the current status of the industry can be obtained, right? They can obtain, like if it is a manager or a person who's CEO of the company, they can view the data from another which could be located maybe in US or something, or somewhere outside the country even. So if also that is one application. Another application is the connectivity between different locations, between Colombo facility and Horana facility also. These two locations across the routers, right? So the routers allow us to connect to the other facility through the internet. So the two facilities also can communicate with each other. So the connectivity between two facilities is also enabled. And then also we can have situations where we have like more complex systems at the edge of the network, right? So maybe sensors to sensors, like they also can communicate, right? Sensors to sensors, they also can correct communication technology is implemented, sensors to sensors, like short range communication must be installed in all these sensors. And then if that is the case, then once a sensor is transmitting certain data to the other sensor, then the other sensor will be able to decode it using the same communication module, right? Let's say LoRa communication module. Then each of the sensor nodes have to install LoRa module in their sensor node, and then they need to decode using the same type of module. Other, right? So this is like something that is may not be in existence in some of the industries in Sri Lanka or in other parts of the country in the world. But this is the concept, like connectivity between sensors or devices or robots, let's say, right? So devices or robots. So I don't know whether it's clear to you, right? If it is not clear to you, you can let me know. I mean, these sensor nodes can be thought of also as like a device, right? So instead of sensor nodes, we can also consider devices, or we can also consider robots. So in that case, the situation where we are able to communicate or establish communication between different sensor nodes, different devices, or different robots is also another aspect of the industrial IoT scenario, industrial IoT networks. So this is what industrial IoT enables. It enables us to create communication links between each of the components of its network, in its network. So between devices, between different locations, different local areas, and between through the internet, between global. I mean, we are connecting to the global network, and then from that again we can connect with another location. Industrial IoT is basically improving the connectivity between the components in the IoT network. So I was talking about the industrial revolution number 4.0. So the main focus of Industry 4.0 was adding connectivity to the devices in the IoT in the industrial scenario, adding connectivity to the components in the industrial scenario, right? So already have you're in the industrial domain, and maybe you're working in you have the experience with the industrial like production lines, and you have worked with them. Maybe like whether this connectivity is actually available in the current factories or not, right? In Sri Lanka, I think there's not much implementation of this connectivity concept so far in the factories. They have some computer based systems, but connectivity is I think not that available. So if I'm wrong, please let me know, and you can share your ideas. So Industry 4.0 is the latest industrial revolution that has occurred in the world, and Industry 4.0 is focusing on improving the connectivity between devices. And for this, we need to implement the industrial IoT networks. So industrial IoT networks. So industrial IoT networks are is a feature. Industrial IoT is a feature of the Industrial 4.0 revolution. So I mean, we call this always we can search in the internet as Industrial 4.0 4.0 version. And then in there, we can see that industrial IoT is one of the main features of Industrial 4.0, right? So we talked about industrial revolution. So we will see like how we can differentiate the different revolution the features of Industrial 3.0 and Industrial 4.0. So also before that, like in industrial scenarios, we connect our sensors to the PLC, right? So this access point will be a PLC mainly. So the PLC is actually able to collect, sensor data, and the, the processing unit as well as the communicating unit. Then we connect the data from the sensors will be sent to the PLC. The processing will happen at the PLC. The communication afterwards will be done by the PLC. So processing be mainly done at the PLC. After that, the data will be sent to the router, which is connected to the maybe to the local area network in the facility. right? So there could be another router in here, which is the router which is available in the facility, industrial environment. And this router, there could be several routers which are in the industrial environment, and through this router, the public internet. So this router could be in the industrial local area network. So we need to do the processing at the PLC and then send the data to the router. And then the router will forward that data to the public internet. So the processing is done at the PLCs. So the processing, I mean, if the sensor nodes, I mean, since the sensor nodes are very large in size, and they are solely used for collecting data at their location, they are not doing the processing at the sensor node level. So they are sending directly the data to the PLC as of now. So the PLC in here can act as the edge device, the local edge device, and the processing can happen here. It acts as the embedded system uh, which is available in the industrial scenario. So PLC act as the uh, embedded system in the industrial scenario. So you know that in normal IoT systems, we have Arduino and ESP32, Raspberry Pi, Node MCU, microcontroller boards to do the processing. However, in industrial scenarios, so that processing will be done by the PLC. So instead of Arduino, we can have PLC, right? But I think I showed you in the previous lessons, we have now the combination of PLC and Arduino. So some PLC versions are there, which allow us to use both Arduino features and PLC features. So sometimes we can code using Arduino, C++ or Python language, and then we can control the PLC. So we have combinations of Raspberry Pi and PLC, and Arduino and PLC systems available for industrial processing, like computations at the edge. Right. So the PLCs are designed to withstand the robust environment in the industries. Not robust, like hard, difficult environment in the industry. So if you have any questions, please ask. So PLCs are very kind of robust processing units, which are available in the racks in the factory units, and they are connected with fiber lines and to the sensors, right? So the sensors send data to the PLCs, and the PLCs do the computation. The PLCs, after doing the computation, will be connected to the routers. Then the routers are connected to the local network in the industry. If the industry is connected to the internet, then the local network will be connected to the internet. Then after that, they can access the cloud server, and the cloud server can store the information of the industry. I will erase this drawing. So what is the difference between Industrial 3.0 and Industrial 4.0? What is the difference between the industrial versions, industrial revolution versions 3.0 and 4.0, right? So the basic thing that we will be focusing here is like what are the new features that are brought by the industrial 4.0 system when comparison to the industrial 3.0, which is the kind of the old version. So industrial 3.0 is also like a very compatible, very good and flexible system that is currently in usage. However, Industrial 4.0 has more advanced features than Industrial 3.0. There are changes in terms of productions, like operations, like under productions, right? So the focus in Industrial 3.0 has been on the manufacturing process. However, like the focus in the 4.0 has been on the product, improving the product lifetime. Okay, so improving the product lifetime. So the 4.0 focuses on improving the product lifetime. Industry 3.0 focuses on the manufacturing process, which means how we can improve the efficiency of the manufacturing process. Then the Industry 3.0 focus on lean manufacturing, like just-in-time manufacturing. That means efficient manufacturing. Efficient manufacturing, like doing the task on time. This focuses on smart manufacturing, like how to optimize the manufacturing in such a way that the production will be done according to the user's needs. Then this 3.0 focus on focus on making decisions based on experience, make decisions based on experience and past data on experience, right? The Industrial 4.0 focus on making decisions based on data. So actually, I said like in here also, I mean, I said about using data. So in here, in 4.0, we are making decisions based on real-time data, like very fast or latest data, real-time and past data, right? So we can use both data types to make decisions, which could be more efficient than making decisions based only on the experience or the past data that are available for many years. So saving money is the main target of like 3.0 version, while in Industry 4.0 it is focusing on creating new income methods. So therefore, like it always seems that Industrial 4.0 is always better than Industrial 3.0 in terms of efficiency, in terms of improving its quality, and in terms of improving the user experience, and also improving the income of the industry, right? Creating more income methods. So Industry 4.0 seems to be more flexible and more like human friendly than 3.0. However, 3.0 is also not a bad version, but it is good actually. But some improvements have been done in the Industry 4.0 more than Industry 3.0. So apart from that, some changes have happened in terms of IT applications in the industrial Industry 4.0 when compared to Industry 3.0. So anyway, so this is based on like product operations, right? Improving the production operations, right? Based on production operations. So the next thing is based on the improvement based on the IT operations, right? So IT operations. So basically, IT and software support has been taken in 3.0 for improving the process of the in the process of the system. So improving the process efficiency and so on. However, the 4.0 has focused on improving the quality of the product, improving the quality of the product. And the 3.0 version focuses on past data for decisions, but I think I have already mentioned that in the previous case, so I will not mention it again. So Industrial 3.0 is using past data for making decisions, whereas we use real-time data in 4.0. Apart from that, defined communications are predefined communications. So defined communications are only allowed communications only. But in here we have in 4.0 we have collaborative communications available in every component of the IoT system. So we have the flexibility to create communication between components in the IoT system, between any component in the IoT system. So we have more flexibility in the 4.0 in terms of establishing communication links. And then we have complex, or I mean simplified IT operations, in 3.0. In the 4.0 version, we have uh, smart platforms, which will provide us the services. So we can take the operations, we can do the operations in these smart platforms. Apart from that, another thing is that in this 3.0, we have single and unified applications to do several tasks. Single unified software applications to do tasks. But in the 4.0 version, we have assistance systems, which as you know, we have AI based assistance systems in a lot of applications that we use currently. So assistance systems are made available in the Industry 4.0 just like that, in order to assist the customer or the employer to do a certain task. So we don't have software applications only, but we are coming up with assistance systems in addition to the software. So these are the improvements in terms of in comparison to Industrial 3.0 available in Industrial 4.0. Right. So basically that is regarding the comparison. Right. So basically the final idea is that industrial IIoT, we call this IIoT, industrial IoT, is focusing on the connectivity between different components of the IoT network. So the connectivity can be between the devices, between infrastructure, right, and between two different places in the public internet. So basically, IIoT is focusing on creating connectivity and creating connectivity between components, connectivity between IoT components, and communicating that efficiently over the internet. between, we'll say, local IoT components and communicating that efficiently across the internet. Across the internet. So cloud computing also can be used to enhance the experience of IIoT. So cloud computing can be used to enhance the experience of right. Those are the things that I wanted to mention primarily regarding IIoT. So if you want, you can now leave the meeting and do the quiz. I will stay in this meeting. If you have any questions related to the quiz, you can ask me. Right now, I think you can attempt the quiz. So it is available in the LMS. So the good thing is you can submit the quiz multiple times. You don't have to be correct at the first instance. You can submit that, and then again you can submit another version. The latest version will be taken by me as your latest or the last submission, right? So is it okay with you? I don't know whether you are okay with the deadline. So since one student asked about that, I do not know your ideas regarding that. Right. So you can leave the meeting if you want, or you can stay in the meeting. If you have any questions, you can ask from me. Okay, so I will stop the recording and I will answer your questions if you have as well.